Welcome back to our next lesson, lesson 2.3, scientific notation with negative powers of 10. You're going to find that negative powers of 10 and positive powers of 10 are very similar. The only difference is when you have a positive power of 10, you go to the right. When you have a negative power of 10, you move your decimal point to the left. Other than that, writing the number in scientific notation and writing the number in standard notation are very similar. Negative powers of 10 show really small numbers, where the positive powers of 10 show really large numbers. Okay, so we're just taking it from a different spot and moving the decimal point again, which is what's giving us our negative powers of 10. And it'll be easy to see once we start looking at a few examples. Okay, so this just basically says what I said. You move the decimal to the right if you have a positive exponent. If you move the decimal to the left, you get a negative exponent. Okay, so when I have my positive exponent, like in my first example, 3.128 times 10 to the third, because it's a positive exponent, I move my decimal point to the right, I finish writing it, and there's my written out number. When I have a negative exponent, the decimal goes in the opposite direction. We hop to the left. So for example, in number 4, 6.12 times 10 to the negative fifth. The negative 5 tells me I'm moving my decimal point 5 places to the left. Move it 5 places to the left, you fill in your zeros, and you get your number 0.0000612. We'll do a couple examples, and as we do the examples, I think it'll start to be more clear on how this works. Let's take a look at our first example. It says the average size of an atom is 0.0000003 centimeters across. Write the average size of an atom in scientific notation. As you can see, that's a very, very, very small number. Okay, one that if we were to do math with, could be kind of difficult. Putting it in scientific notation makes it a little bit easier if we want to multiply or divide our really large or our really small numbers. Because we know we're taking a really small number and writing it in scientific notation, we know we should have a negative exponent. Our steps are still the same though. We start with 0.000. There's 7 zeros. I just want to make sure I get them all. And a 3. Okay, writing it out could be one of the difficulties. So if you can, sometimes you want to just do it right on the problem. But I want you guys to be able to see it a little bit easier. So I still need to move my decimal point until I get a number that's greater than 1, but less than 10. So I move it 1, 2, 3, 4, 5, 6, 7, 8 times. Once I move my 8th time, I have the number 3, which is greater than 1, but less than 10. So I get 3 times 10. Since I made a small number larger, I have a negative exponent, and I hopped 8 places, so it's 3 times 10 to the negative 8. Okay, the steps are the same. Just because I'm making a smaller number in scientific notation, I'm going to have a negative exponent. Larger numbers, you're going to have a positive exponent. Pause the video, try the return section on your own, come back and check your work with me. All right, so let's take a look at a couple other examples in the return section. Like I said, make sure you pause the video, try them on your own, then come back and look at my answers. Number 4, we have the number 0.0000829. Okay, so I start from my decimal point and I want to move it over until I get a number that is greater than 1, but less than 10. 1, 2, 3, 4, 5. I stop here because 8.29 is greater than 1, but it's less than 10. Okay, I write that number down, 8.29 times 10. Since I'm making a small number big, I'm going to have a negative exponent, and my exponent is just how many times I had to move it. So 1, 2, 3, 4, 5. So it's 10 to the negative fifth. Okay, let's look at number 5.00, and sometimes I have to cross out the zeros to be able to tell how many I need to write. 0.00302. Okay, so I start from the left. I go 1, 2, 3, 4, 5, 6, 7 times. So I write my 3.02. That's my number that's greater than 1, but less than 10. I'm always multiplying times 10 to the something. Because I'm making a smaller number large, I know it's a negative exponent, and I moved it 1, 2, 3, 4, 5, 6, 7 times. So it's 10 to the negative 7th. Okay, number 6 is our last one. It says a typical blood cell in a human blood has a diameter of approximately 0.00 0.0007 meter. We want to write this in scientific notation. I'm right here. Okay, so I want to move it until I get a number that's greater than 1 but less than 10. I can tell right now my 7 is going to be my number. So I go 1, 2, 3, 4, 5. I move it 6 places to get to 7. And I have 7 times 10. Again, I moved it 1, 2, 3, 4, 5, 6 places. So it's times 10 to the negative 6. That's writing it from standard notation into scientific notation. Now we're going to work from scientific notation and put it back into standard notation. And that works the same way it did with positive numbers, just going in the opposite direction. So example 2 says platelets are one component of human blood. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meter. Write 2.33 times 10 to the negative 6 in standard notation. So I start by writing my number out, 2.33. Okay, and my negative 6 tells me I'm going to move 6 places to the left. So I start from my decimal. I go 1, 2, 3, 4, 5, 6. Anywhere I have a blank spot, I fill in with zeros, and my decimal point goes at the very end. So it's 0.0000233, which obviously is a very small value. And that makes sense. The larger our negative exponent is in scientific notation, the smaller the number we actually have. So pause the video, try and do the next few on your own, come back and check your answers with me. So let's start with number 9. For number 9 we have, let me get out of that. So for number 9 we have 1.045 times 10 to the negative 6. So the negative 6 tells me I'm going 6 places to the left. Start here, 1, 2, 3, 4, 5, 6. And I fill in my blank spots with my 0. I put my decimal point at the end. So I have 0.0001045. Okay. It's really the same process repeating over and over again. So we start with 9.9. This time we want to move it 5 spaces to the left because it's a negative 5. 1, 2, 3, 4, 5. Fill in with zeros. I get 0.00099. And number 11, we have 1 times 10 to the negative 2. Remember, if there's no decimal point, it's a whole number, and that means the decimal point goes to the right. I put my decimal point in, and I go 1, 2 places. I fill in my 1, 0, and it's 0.01. So that is negative powers with scientific notation. It's not that much different from positive powers. It's just when you have a negative power, you know you have a really small number. So I hope this makes sense. If not, please feel free to ask questions, leave a comment, or do whatever you have to do.